In Euclidean geometry, a regular polygon is a polygon that is equiangular and equilateral. Regular polygons may be convex or star. In the limit, a sequence of regular polygons with an increasing number of sides becomes a circle, if the perimeter is fixed, or a regular apeirogon, if the edge length is fixed. General properties. These properties apply to all regular polygons, whether convex or star. A regular n-sided polygon has rotational symmetry of order n. All vertices of a regular polygon lie on a common circle, that is, they are concyclic points. That is, a regular polygon is a cyclic polygon. Together with the property of equal length sides, this implies that every regular polygon also has an inscribed circle or incircle that is tangent to every side at the midpoint. Thus a regular polygon is a tangential polygon. A regular n-sided polygon can be constructed with compass and straight if and only if the odd prime factors of n are distinct from at primes. See constructible polygon. Symmetry. The symmetry group of an n-sided regular polygon is dihedral group Dn, D2, D3, D4. It consists of the rotations in Cn, together with reflection symmetry in n-axis that pass through the center. If n is even, then half of these axes pass through two opposite vertices, and the other half through the midpoint of opposite sides. If n is odd, then all axes pass through a vertex and the midpoint of the opposite side. Regular convex polygons. All regular simple polygons are convex. Those having the same number of sides are also similar. An n-sided convex regular polygon is denoted by its occurrence Flea symbol n. Henagon or monogon 1 degenerate in ordinary space. Digon 2 a double-line segment degenerate in ordinary space. In certain contexts all the polygons considered will be regular. In such circumstances it is customary to drop the prefix regular. For instance, all the faces of uniform polyhedra must be regular and the faces will be described simply as triangle, square, pentagon, etc. Angles. For a regular convex n-gon, each interior angle has a measure of degrees, or radians, or full turns, and each exterior angle has a measure of degrees, with the sum of the exterior angles equal to 360 degrees or 2 radians or 1 full turn. Diagonals. For n greater than 2 the number of diagonals is, that is, 0, 2, 5, 9. For a triangle, quadrilateral, pentagon, hexagon, the diagonals divide the polygon into 1, 4, 11, 24 pieces. For a regular n-gon inscribed in a unit radius circle, the product of the distances from a given vertex to all other vertices equals n. Interior points. For a regular n-gon, the sum of the perpendicular distances from any interior point to the n sides is n times the apothem. This is a generalization of Viviani's theorem for the n equals 3 case. Circumradius. The circumradius of from the center of a regular polygon to one of the vertices is related to the side length s or to the apothema by. The sum of the perpendiculars from a regular n-gon's vertices to any line tangent to the circumcircle equals n times the circumradius. The sum of the square distances from the vertices of a regular n-gon to any point on its circumcircle equals 2nr2 where r is the circumradius. The sum of the square distances from the midpoints of the sides of a regular n-gon to any point on the circumcircle is 2nr2 4, where a is the side length and r is the circumradius. Area. The area A of a convex regular n-sided polygon having side s, circumradius r, apothema, and perimeter p is given by. For regular polygons with side s equals 1, circumradius r equals 1, or apothema equals 1, this produces the following table. Of all n-gons with a given perimeter, the one with the largest area is regular. Regular skew polygons. A regular skew polygon in 3 space can be seen as non-planar paths zigzagging between 2 parallel planes, defined as the side edges of a uniform antiprism. All edges and internal angles are equal. More generally, regular skew polygons can be defined in n-space. Examples include the Petrie polygons, polygonal paths of edges that divide a regular polytope into 2 halves, and seen as a regular polygon in orthogonal projection. In the infinite limit, regular skew polygons become skew apeirogons. Regular star polygons. A non-convex regular polygon is a regular star polygon. The most common example is the pentagram, which has the same vertices as a pentagon, but connects alternating vertices. For an n-sided star polygon, the Slocurrency Flea symbol is modified to indicate the density or starriness m of the polygon, as nm. If m is 2, for example, then every second point is joined. If m is 3, then every third point is joined. The boundary of the polygon winds around the center m times. The regular stars of up to 12 sides are, pentagram euro 5/2, heptagram euro 7/2 and 7/3, octagram euro 8/3, enneagram euro 9/2 and 9/4, decagram euro 10/3, hendecagram euro 11/2, 11/3, 11/4 and 11/5, dodecagram euro 12/5. M and n must be coprime, or the figure will degenerate. The degenerate regular stars of up to 12 sides are, hexagram euro 6/2, octagram euro 8/2, enneagram euro 9/3, decagram euro 10/2 and 10/4, dodecagram euro 12/2, 12/3 and 12/4. Depending on the precise derivation of this Slocurrency Flea symbol, opinions differ as to the nature of the degenerate figure. For example, 6/2 may be treated in either of two ways. For much of the 20th century, we have commonly taken the /2 to indicate joining each vertex of a convex 6 to its near neighbors 2 steps away, to obtain the regular compound of two triangles, or hexagram. Many modern geometers, such as Gra 1/4 NBAUM, regard this as incorrect. They take the /2 to indicate moving 2 places around the 6 at each step, obtaining a double wound triangle that has 2 vertices superimposed at each corner point and 2 edges along each line segment. Not only does this fit in better with modern theories of abstract polytopes, but it also more closely copies the way in which Poinsot created his star polygons by taking a single length of wire and bending it at successive points through the same angle until the figure closed. Duality of regular polygons. All regular polygons are self-dual to congruency, and for odd n they are self-dual to identity. In addition, the regular star figures, being composed of regular polygons, are also self-dual. Regular polygons as faces of polyhedra. A uniform polyhedron has regular polygons as faces, such that for every 2 vertices there is an isometry mapping one into the other. A quasi-regular polyhedron is a uniform polyhedron which has just 2 kinds of face alternating around each vertex. A regular polyhedron is a uniform polyhedron which has just 1 kind of face. The remaining convex polyhedra with regular faces are known as the Johnson solids. A polyhedron having regular triangles as faces is called a deltahedron. See also, tiling by regular polygons, Platonic solids. Apeirogon an infinite-sided polygon can also be regular. A list of regular polytopes, equilateral polygon, Carlyle circle, notes. References, Coxeter, HSM regular polytopes. Methuen and Company Gra 1/4 NBAUM, B. Are your polyhedra the same as my polyhedra? Discrete and compact. Jam, the Goodman-Pollack Festschrift, ed. Aronoff al., Springer, ppA 461 euro 488. Poinsot, L. Memoir sur les polygons et polyhedres. JDLA Permil Cole Polytechnique 9, ppA 16 euro 48. External links, Weierstein, Eric W., Regular Polygon, MathWorld. Regular polygon description with interactive animation, in circle of a regular polygon with interactive animation, area of a regular polygon 3 different formulae, with interactive animation, Renaissance artists' constructions of regular polygons at convergence.